Okay, so here are some of the examples. I should have probably done this ahead of time, but it's too late now. Here are some of the examples from section 10.2. We're trying to figure out, that looks good, they're good enough. Which number sets these belong to. Sorry, excuse my thumb. There we go. And write whole, integer, rational, or irrational. Now the key is this, to recognize that what a whole number is, what an integer is, a rational and an irrational. And that if you're a whole, you're automatically an integer and rational. And if you're irrational, you're neither of those. Okay. So like number 14, a whole number is a number like number 4, where it's not a fraction, it's not negative, it's positive, and so it's just all one thing, it's whole. So that would be a whole, but it'd also be an integer because integers are just positive and negative whole numbers. And it'd also be rational because of the fact that I can write 4 as a fraction by putting it 4 over 1. Okay. If I jump ahead to like number 16, 16 is not whole or an integer because it's a fraction, and it's not a radical, so it is rational. Okay. 17 is irrational because that's a radical that can't be simplified. That's really our only way of having irrational numbers right now is that. Jumping ahead, 18 is tricky because it's really negative 9. Negative 9 makes it an integer, a rational, and a rational number. Number 19 is just rational because it's just a decimal that ends. And then same thing for 20. 20 is a decimal that repeats. That's really 5 over 9. So it's irrational. So it's rational. Okay. Really after that, there's only one that's irrational in the entire assignment. That's 17. This is rational because it's a fraction. It's 18 over 99. This guy here is 12, so he's whole. And he then means he's integer and rational. Same thing here. This is 6, so it means it's whole, integer, and rational. This guy's just straight up rational because he's a decimal that terminates. Okay. Number 26, 27, and 28. These you get to use your calculator with. You kind of have to. There are ways to get around it, but the way our book presents it, they just use the calculator. So we have to do the square root of 17. It is 4.12, which is less than 4.2, so 26 is less than. 27, 5.15 repeating, and the square root of 26. That's 5.099. So this guy is bigger because he's 5.15. This is 5.09, so larger. This is the one where they try to get tricky. Square root of 10, first of all, is 3.16. So I know this is 3.16. But I have to remember what 3 and 5/6 is a fraction. It's 3.83 repeating, but if you didn't know that, just do 5 divided by 6 in your calculator. You get 0.83 or 0.83333333. So that's 3.83 there. So okay, 28 is greater than. Okay. Then for 36 through 40, okay, just kind of run through those real quick. 36, I've got y squared equals 64. So we solve by taking the square root because square roots undo squares. So for 36, the square root of 64 is 8. However, we talked about in class, the actual answer is plus or minus 8 because if you square negative 8, you get negative 8 times negative 8, which is positive 64. For a number like 38, you have to divide by 5 first. Then 315 divided by 5. Kind of feeling lazy now. That's 63. I can do that in my head. So 63. The problem is then when I take the square root of that, I don't get a square root. So that's where the book talks about writing to the nearest tenth. So it's plus or minus, and we'll see what the square root of 63 is. It is 7.9. Yeah, 7.9. And then 40. If we look at that one, same thing. First thing you do in 40 is divide by 1.5. I don't even want to try to pretend like I know what that is off the top of my head. Sure, something too big. Yeah, 127. And then take the square root of both sides. 127 does not have a square root, so we'd have to use the calculator to approximate it again. And that is 11.3 to the nearest tenth. And again, don't forget the plus or minus. Okay, so there are problems for section 10.2.